So guys, welcome back to another video, and in this video we are going to be talking about the Swift programming language. Now, why is this video on Swift? The previous one, as you know very well, I uploaded a video on Kotlin multi-platform, and I decided to make a series of videos on it. But I feel it would be much better if viewers knew a little bit of Swift as well as Kotlin before, diving into building mobile applications. Hence, I decided to make a video on essentials of Swift programming, and as you guessed, there will be one more video on Kotlin as well before we dive deeper into the Kotlin multi-platform environment, Kotlin multi-platform framework actually. This video will be a little bit fast as I wanted to bring in as much as I could. So yeah, let's get started, guys. Now, every programming language has more or less the same learning pattern. You start off with data types and then keep progressing into control statements, conditionals, functions, asynchronous stuff, and so on. So yeah, let's start with data types. This is a Swift playground. That you can create using Xcode. You need to have Xcode editor, guys. I'm using the Xcode 15 as we speak, 15.1, I guess. And it could be any version, but if you want to follow along and yeah, you could just go ahead here, create new playground, and then give next and create one. That's it. So I have already created one here, and let's get started. Now, if you already have done a little bit of programming before, then this video is going to be really useful for you guys, because Swift isn't much different from the other programming languages out there. Now, let's get started, guys. But even if you're a complete beginner, I got you covered. That's what I'm trying to say here. You will clearly understand what's being covered here. Just follow along with the video. And if you have the small, I hope you can see these. If you have the small character thing, that's like the carriage return, guys. If you hit enter, you can see that, right? So to make those go away, what you can do is just go to editor and then click on invisibles if you don't feel uncomfortable. If you feel uncomfortable seeing them. Anyway, let's get started, guys. As for the basic data types, we'll start with the integers. Integers are primarily used to hold numbers, like you guessed. To create an integer, all we have to do is var first number equals 15. That's it. First number is a variable holding an integer now. And you can do operations like first number plus, you can just increment this and do other stuff. I'll just show you one. There are plenty of stuff that you can do with integers. I'll just show you one and then we'll move on, since we got a lot of ground to cover. Say, for instance, I can do an operation like this: first number dot quotient and remainder dividing by 4. So this will obviously divide this number by 4 and then keep the quotient and remainder here, which can then be printed onto the console. To print onto the console, just use print second number dot quotient. Fine. Now let's run this and see, so that you guys can have an idea of what we are like. So you can see that it's 4 here, right? For some people, console might not be visible. Just click on this small button here and it will become visible. That's it. And let's move on. So now we have doubles. Doubles are used for holding decimal numbers, obviously. Now this is a double. This is a double. This is also a double, guys. This is an integer, whereas this is a double, right? Now, double similarly have operations, like a lot of inbuilt operations that you can try out on your own as well. But in essence, double, CG, float, these are used to hold decimal values. And obviously, we have the Boolean data type, which is used to hold true or false binary values. So you can just hold it true is flagged dot toggle. Yeah. So this will obviously change the whatever is set, it will toggle it to the other value. That is, if it's set to true, it will become false. If it's false, then yeah, the binary operation, as you can say, as you probably guessed. Now let's talk about strings. Strings are essentially text. Yeah. So I can just create a string like this, where greeting equals hello. This is a string. That's it. Now, since this is a var, this was created using a var keyword, I can change this. Greeting equals hello there. But if this is a let some string equals hi. Now this can't be changed. If I change it like this, it will show substring is a let constant, which means throughout the entire execution of this code, this some string is just going to hold this value and it can't be changed throughout the entire execution of the code. Whereas if I create a variable with the var keyword, then that could be changed. It's not a constant, it could be changed over time. That's it, right? So that's one thing that I wanted to show. And what else? Obviously, this has other stuff as well, like say for instance, print greeting dot contains, you could like you could do something like this, and it will return a boolean value that is true. See, right? So we'll just remove this. Yeah, it will return a boolean value true. And you could also like true string interpolation. I can simply do like welcome, or I can't simply do hello there. If I do this, it will show an error, guys. So to do some proper string interpolation, what you need to do is you need to like put a backspace here to denote that there is something coming up, and then within brackets just do the greeting. So now if I just run this, watch what happens. Hello there, right? Since this is, yeah, now this obviously seems stupid, so I'll just remove this and then put my name below. Hello there, Raja. So yeah, this is one way of doing it. This is how you handle string interpolation, and there is something called binding, which I'll explain a little bit later. So this is strings, guys. Now there are obviously other data types. We'll quickly run through them as well. Say for instance, there is something called an array. Now arrays, once again, if you have already done some programming, you would be pretty much familiar with arrays. If not, it's just a fixed, like consider that it's like a set of, not exactly a set, it's just a set of values with the same data type. So let me create an array so that I could illustrate an example here. So if I do just var numbers equals 5, 6, 7, this is an array. All three elements have the same data type, which are integers, right? This is an array of integers. So now if I want to do like an names equals, I can do like 4 of them. Raja, Vince, Tommy, Steve, right? Now this is a array of strings. I can do operations, array operations like strings dot insert and Mike. Where do I want to insert it? I could insert it at index 1. So this is 0, 1, 2, 3. Now if I print the names, names. Now if I make mistakes, guys, just like, now if I print names, it will be showing Mike in between Raja and Vince, right? It should show Mike in between Raja and Vince. Let's just see if that's the case. Yeah, as you can see, it's doing its duty. You could also do like, for instance, names dot contains. You can check if the string contains, if the array contains something, like for instance, let me just put in a name here. Vince, right? Now this will be a boolean. If the names contains a variable called, a character or a string called Vince, it will return true, and if not, it will return false. That's it. Yeah, that's it. Similarly, similar to array, there is something called, these are all coming under the same protocol called collections. Anyway, there's something called dictionary, guys. Dictionary, I'll just move on with sets first and then show you dictionary. Sets are nothing but they're similar to arrays, but they don't have any specific order, and also they store only distinct, like for instance, let me show you distinct. Here I haven't specified any data type, right? Similar, you can give a data type like this to specify that it's an integer of arrays. Here I haven't like explicitly given it, but yeah, you could do this. Here you could like do to denote that it's a string. Yeah, you could give it like this, explicit type declaration. Anyway, where distinct names equals, even if I do like, for instance, let me show you. Set Raja now if I just print this, watch what happens. Watch what happens. Raja mark and see, even though I have given 2 Rajas here, it just prints only 1, right? So there are no duplicates in sets. That's exactly what I'm trying to say here. And even if I like, I'll remove this print statement. Even if I like want to even if there are like 100,000 values in a set, if I want to pick one, it will do that like instantly. So I could just do like print distinct names dot contains steel. It's a true value, right? Let me do false. Jamie. You can see that it's instantly showing it up as false, right? Even if there are like hundreds of thousands of values inside a string, set, it'll run instantly, guys. That's a huge advantage of using sets when you're writing a Swift program. Now let's move on. Let's move on from sets. I wanted to show you guys dictionaries as well. Dictionaries are okay, I can't spell sometimes. Dictionaries are nothing but key value pairs stored similar to an array, right? So what it look like, where player positions equals name you can see this, right? So this is a key value pair that's being stored in the form of an array. That's what exactly dictionary is. Oh, here I haven't. Yeah, that's exactly what a dictionary. Dictionary as well can have like a type. Here I can just give dictionary. If my values are going to be numbers, say for instance, I want to store marks of a student across different subjects, then obviously this would be int. You get my point, right? Of declaring a type explicitly. Anyway, this is showing up an error because, yeah. Now, if I can do stuff like player positions of name, and I need to like default. This I'm doing specifically because if the dictionary doesn't have a key called name, obviously it can't return anything, right? It can't return a name. It can't return an output. So in that case, I need to specify default value to show that there is no. I'll say show that. Why am I speaking a lot? Okay, this. I'll remove this. Now if I run this, it's showing Costa, right? The name. If there is no key called names. Now if I run this, watch. It's showing not specified, right? So if in case it's not found, if the key is not found inside a dictionary, you need to set a default value, specify default value so that will get printed instead of something like null or something, right? So yeah, that's dictionaries, guys. And there's one more step, enumerated data type, as you know, obviously from other programming languages. We have enums here in Swift as well. So to do that, you just like do member status, for instance, and then case active. Use enums only when you know the outcome of logic that you are about to write. Mainly, particularly used for error handling. For error handling, this is a beautiful use case, guys. Enum is a beautiful data type. Anyway, inactive member can be active, inactive, or disabled. Okay. Now, if I want to like var stat equals member status dot, yeah, as you can see, I get all the three cases, right? So I can like do like an inactive in case he is away from his keyboard. Yeah. So that's the enumerated data type, guys. And enumerated data type to you can even use that inside a switch statement. Anyway, play around with it a lot, guys. This is the data type stuff, the basic data type stuff that I wanted to talk about to you guys today. Play around with it a little bit to familiarize yourself. I'm pretty sure if you have already done programming before, then this is pretty much easy for you guys to grab onto, since it's similar to several other object-oriented programming languages out there. Let's move on. So once you have like you have a little bit knowledge on data types, the next thing you need to look for in a programming language is conditional statements, right? Conditional statements alter the flow of the running program. While the program is in execution, conditional statements alter the flow of a running program. That's it. So let's go ahead and start looking at some of those along with some examples. So this is data types. Now I'll do conditional statement. The first thing we'll see is if statement. Okay, you probably know this already. If this is equal to something, then do something, that's it. And else if is, like you guessed it, if it's not equal, then do this. Else if Mike is, just check this condition, equals Mike. And else is if nothing is true, do this. Well, okay, this is pretty much simple, guys. That's why I'm just messing around with you. If, else, if, and else are pretty much common in whichever language you decide to like go with. So yeah, let's not spend too much time on this. If your name is, this is obviously false, this is true, and yeah, since this is true, this won't execute. It will just print your name is Mike, as you can see here, just as we are speaking. And obviously if this is false, this will be printed. So let's move on, and you can chain two conditions as well. Say for instance, let count equals 56. Now I can chain two conditions, like if count less than 60 and count greater than 50. Now if I run this, yeah, it is in range since it's 56. And as you know, this is an AND operator, this is a OR operator. Even if any one of this condition is true, it will always return true. That's it. So yeah, that's one thing. And then let's talk about switch statements. If you have like multiple cases that you need to handle, you can use switch statement. So if I dash to switch, what was the enum that we had before? Does anyone remember? Stat, switch, stat. There were three cases, right? So case active, case disabled, and you need a default case. Default. Now if I run, I'll remove all these. If I run this stat, what was it that you gave? Inactive, right? So it will be unspecified. So if I give this to active, you get it, right? If I give this to active, it will show yes, he is active. That's it. So when you're having multiple cases to deal with, you can use a switch statement. These are all like very basic concepts that you might learn. Anyway, let's move on. So there is something called ternary operators. Let valid value equals. You can just write the condition in the same line. That's it. Count great. It's much simpler, guys. Count greater than 40. If it's true, then print valid. If it's not true, then print invalid. Now in a real situation, this won't be as simple as this. Here you will be calling another function. You will be calling a function if a condition is satisfied. You will be calling another function if a condition is not satisfied. So yeah, if you just print this out now, I'll just this is obviously valid since, yeah, I'll print this out, comment this out as well. These are ternary operators. Now the real fun stuff comes when the flow is handled using loops. Loops are something that you can use to like make the same piece of code run over and over again until you have like a until the number of times that you have specified. So there are like primarily two loops that we would use in common. One is the for loop and another one is the while loop. For loop is pretty much self-explanatory loops. So like I can do, I had an array before, right? What was that? Numbers. For name in, for single number in numbers and print hello single number and single number doubled is number into 2. What's this? 5, 6, 7 is nothing but the numbers that we had here in this array. I'm simply reusing that array here, and if I'm running a for loop inside that array. So for each and every instance, for each and every value in that array, it's simply printing that value and then multiplying it by 2 and printing it again. That's it. It's a simple for loop, guys. If you want to like take a range of stuff, like for instance do like a for underscore. Underscore can be used when you don't want to explicitly specify, say for instance for some number in a range of numbers 1 up to less than 5, 1 through 5. Okay, so if I do print my name is Raja for the time, I'll comment this out so that I'll comment this entire thing out so that you don't get confused. Now watch this. For the first time, for the second time, for the third time, for the fourth time, right? Here I'm explicitly using the sum number here, but in case I'm not using this at all. Now the sum number is not used anywhere here, right? So what you can do is you can simply do an underscore for stuff that you don't use. So now if I do 4 times, it will print 4 times since it's less than 5. If you want to include 5, if you want a range, just give 3 dots. And if I do it now, as you can see, it's printed 5 times, right? So this is another way of like creating for loops. These are simple stuff, guys. Once again, now let me show you while loops. While loops are interesting as well. Say for instance where I'm doing it, where new counter, let me just scroll this down, where new counter equals 7, while new counter greater than 1, new counter minus equals 1, which means the value of new counter will be reduced by 1. And since this is happening, cool. Now I'll just comment this out, and if I run this, you can see it's at 6, 5, 4, 3, 2. Since I have given greater than 1, obviously it's not going to be printing 1. Now some of you might wonder why it didn't print 7, right? Since it should start with 7 and since it should go up to 2, some of you might wonder why it didn't print 7 and why it has printed 7. I just didn't scroll up. So yeah, it's a little bit hidden, guys. Now you can see, right? Anyway, let's move on. This is the while loop, and you can also use continue and break statements to break the flow from inside a loop or to continue the flow. Wait, I'll show you. Here, let me do this, or I'll once again do this entire thing. Let all numbers equals okay, I have a list of numbers. I have an array of numbers for single in all numbers if single dot anything is multiple of 2. Fine. Continue. You get what I'm doing here, right? Okay, just run. I'll run this. Yeah, now you get what I'm doing here, right? If it's a multiple of 2, just continue. Continue the loop execution. Ignore whatever is below it, below the continue statement. If it's not a multiple of 2, print that particular value. So if I do from 1 till 9, 1, 3, 5, 7, 9, the odd numbers would get printed. Since the even numbers have, the even numbers satisfy this condition, right? So yeah, that's exactly what is happening here with continue. Similarly, there is a statement called break, which is used for breaking out of the entire loop flow and then like continuing on with the rest of the program. So that's loop in an essence, guys. Let's move on. We already have covered data types, conditional statements, and loops, right? So let's move on. Let's keep moving. Now let's talk about functions, guys. Functions. Now we are getting into the interesting parts of the Swift programming language. Functions are pretty much small pieces of code that you write here and there that you can call from another part of the same program or from a different file that you can like use anywhere throughout your entire application. So I'll show you like a basic function. Function print age. You just prefix that with the func keyword. That's it. Print age, and then this will accept a number which is an integer. Now to call this, all I need to do is print age 54, and if I run this now, age is 54, right? So this is exactly what I mean. I can call this print age function from anywhere. It's a basic function that I have just created. Let's see another example. Okay, this is just like a primitive preliminary function. Let's see different example. Function, let's say we'll have a roulette rule. This will return a integer data type. So to make sure that it returns an integer data type, you need to specify it like this, and then return int dot random. I think that will be like 36. Let's just assume that it's 36 random in range 0 to 36. So this function will now return a value that's anywhere between 0 to 36. So every time I spin this roulette, you see this, right? It's 11. Each and every time I run, it will show a different number since it's a random number. So what I'm trying to say here is functions can also return values of a specific data type. Here it's returning a number, right? So similarly, it can return anything like a string or an array or anything. Now, if you want to like skip a specific, how do I say this? If you want to skip like a specific variable that you are not going to be using inside the function, you can once again, like I said before, you can use an underscore, right? That's one thing. And there is also like an external and internal naming naming way. I'll show you an example for that as well. Now, regarding the passing of parameters inside passing of values to a function, I wanted to mention something. Say for instance, this is like a function print my name, and then my name, this is a string. Now, whenever I call this print my name, I need to specify this as such. This should be the same as this. So if I want to specify a string here, I can't just give like this, or I can't give like this. You need to specifically throw in this my name, otherwise it won't work, guys. Or you can use an underscore if you want to like ignore the thing completely. This is a standard way of doing it in Swift. Now there's something called external and internal naming, guys, which I wanted to show you specifically. Say for instance, I have a function called getStatus. Okay, and if I'm about to pass a value to this function and I don't want to like collect it here, I can simply do it like this. Fine. And otherwise, if you, okay, I didn't talk about that, right? Say for instance, getStatus status boolean, and then this has a return. Say for instance, this has a return type boolean. Okay, keep it like this. Let's keep it this. This is a function. It accepts a value of status. So whenever I call this, I need to give this explicit argument label here. This should be used. If I didn't use this, watch what happens. It will throw up a specific error mentioning the same thing. It will say like argument label status is missing. So whenever I want to do this, I need to specify this. argument label. So if I want to give this without the argument label, what I could do is, obviously you guessed it, I need to use a underscore, and to get this to read this passed value inside this particular function, what I need to do is I need to have like a local reference here. Do you get it now? This value is passed down into this function, and this value can be referenced using this my status, say for instance. Now this will return a, okay, this doesn't make sense. Let some status equals yeah. Now we can get it right. Now I have a variable, I have a constant that has a value of online, and then I'm calling this particular get status function with this constant, and I'm using a variable here to receive this string constant here, and then I'm checking the value against a predefined condition. Now if I run this, watch what happens. Nothing will happen because obviously I haven't printed anything, right? So let me just print this, and then this is not needed. It's returning true because this has been passed down and this has been received in this. This is what I said when I said external and internal naming, guys. Here you don't need to pass a name because I've used an underscore here, but in order to reference the passed down argument, you have this my status identifier, and you are using this my status identifier to check the passed down value against the predefined condition. If it's true, then obviously it's returning true. If it's false, then obviously it's going to be returning false, which is what's getting printed here. I think you would understand this, and I hope I haven't confused you, but let's move on. There is something called tuples, guys. Tuples are specific. I'll show you. It's better to show tuples than talking about it. Function get profession, say for instance profession, and then I have a tuple. It will return a tuple name, string, job. Assume that it will return a couple of things like this: return name Johnny Depp, job actor. This is a function. If I just do let prof equals get profession, I can access this keys from this particular constant. So I can just do print name and job and just do prof.name and once again prof.job. You get this, right? So tuples are for returning specific key value. Okay, if I run this, watch out happens. Let's move on, guys. Let's move. This is pretty much self-explanatory, I guess. If you follow through the code, you will obviously get it. And there are different ways of writing functions, guys. Say for instance, you can do function. Say for instance, you have a function called get height. Inside this, you can do like this: age int. And then specify a value here. Obviously, since double is 4, it's going to be printing, as you guessed. Oh, I haven't called that function anywhere. Anyway, let me call it with height 54. I can directly use a number here because I have given underscore. But here I can't use it because I need to specifically use this argument label. And if I give obviously 6.2, this is going to be qualified. If I give any value less than 5.2 is still greater than 5. Disqualified. I can even skip this entirely. This will still work. So yeah, that's functions, guys. I hope I haven't like there are still a lot of different stuff that you could do with functions. I hopefully cover this. Functions alone could be covered separately, and I could like make an extended video out of this. But since this is going to be like a video that's touching only on the very basics, I'll just move on from functions to more interesting stuff. Now, before moving on, I'll just talk a little bit about error handling. Okay, and once error handling is done, let's move on from functions. So if you remember, while talking about enums, I said enums are excellent for handling error cases. Let me just use an enum to illustrate my point. Enum verification codes error case alerted invalid. Now in India, okay, so now I'll write a function to verify a code. So func verify code. This should throw an error. Okay, so throws if pin code equals 1 2 3 4. Now in India, we have a specific system that will send an alert message to the bank if you type your PIN code in the reverse. So I'll write a condition for that as well. If PIN code equals, okay, I don't have like a way to reverse the typed PIN code, or can I just just write a function? That's not reversing a number. Should be pretty much easy for a programmer, right? Let's just wing it. Accepts an integer, returns an integer, returns the reversed integer. So where result equals 0, where input number equals number. So I have the integer stored in an input number. So as long as it's not 0, while input number not equals 0, result equals result multiplied by 10 plus input number mod 10. Okay, this will return the reversed number. This will actually multiply by 10 and then, okay, reversing a number is pretty much simple, guys. Ones, tens, hundreds, thousands, that's like a 4-digit number, right? So if you mod 10, then you'll get the remainder which you need to multiply by. Okay, but reversing a number is pretty much easy. You need to like splice off the last number one by one and keep putting it in the front until you get a reverse number. That's it. That's exactly what I'm doing here. So once it's reversed, it will, okay, do this, and then, do you guys get what I'm doing here? I'm using a try catch, try verify code. This is our thing, right? Verify code 1 2 3 4. I can simply use 1 2 3 4 since I have used a underscore. Now to catch this thrown error, and I need to specify a catch block for catching all the rest of all the errors. So print please try again. Now if I send this, what it will do is it will try to reverse this number, and If the reverse number is the same as the pin code, then it will throw this error. If not, it will return verified. So let me just run this and show you what happens. It's showing verified. I will remove all this. Now it's showing verified, right? Watch what happens when I reverse this number. Authorities have been notified. So this is the correct use case, but if I give it in a reversed form, it will just say authorities have been notified because I have a error handling code called in the alerted. I guess this is a complex example. I got drawn away into this, but yeah, now you get how to handle errors, right? You just need to have an enumerated type containing all the errors, and then what you need to do is simply start throwing the errors from the function. If in case you identify a condition that is supposed to throw an error, throw that error, and while calling that function, use a try catch paradigm, use a do try catch. So what this will do is catch this error, and if it is this error, you can just say authorities. A simpler example would have been just to show like catching an email address, guys. If the user types an email address and the email address doesn't have like an @ symbol, or the email address is too short or something, I could have just validated the email address, or type a password, and then if it's below a particular character count, I could just validate that and throw the errors. That's just one scenario. Here I have done like a little bit of complex example, but I feel like you get the point here, right? So yeah, this is exactly how you handle errors, by throwing them and catching them using a try catch paradigm in Swift. Let's move on to closures. Closures are another interesting. Okay, I'll show you closures. Let greet user Now if I call this greet user, watch what happens. First I'll close. Watch what happens. Right? This is a closure. Closure is nothing but it's more like a function that's being returned to a variable, or it's not even a function. How do I say this? It's like a computed function. It's like a computed value that's being returned to a particular constant or a variable. That's exactly what a closure is. And closures are highly helpful while coding, guys. I know this example is kind of stupid, but there's a ton of useful things here that you can do with them once you know how to use them. Say for instance, I'll show you a different example. I'll show you trailing closure. I'll show you a simple example. Let attendance equals 40, 55, 75, 56, 32. Assume that these are the number of days students have appeared for classes. Let resultant equals attendance dot filter, and then simply do like a counter int you see what I have done here, right? This will return a boolean. I'll show you. Only when the counter is greater than 50, those values will be returned to resultant. If I run this, watch what happens. You get what I'm trying. So whoever has an attendance percentile that's greater than 50, only those guys are eligible for taking up the tests. This is another example of a wonderful example of a closure. So not only I am just doing something inside this attendance array, I'm doing something that's completely custom. I want to run this condition. It's like more like a condition that I have specified for my own needs, but I'm able to do this on a built-in data type. That's an excellent thing. If you are like coding like a very large complex application, this can come in quite handy, guys. Now this could even be reduced further and further, right? Let me show you. The same thing can be reduced as, maybe, this would still print the same thing. This could be even further reduced. Let result time. And I can simply do okay, I don't have a print statement. So yeah, you see this, right? So yeah, this is a closure, guys. This is a closure. There are like different types of closures that you can like use on existing data types to make whatever you want. Let's talk about structs next. Structs is more like you can build like a completely custom data type that contains other data types. So they're not just data types. It could even contain functions. So if you're making a struct, you can use that specific struct somewhere else inside your program whenever it's needed. This contributes to reusability of code a lot. Let me show you an example rather than talking about it, so that you guys can have a better idea of what I'm trying to say here. Structs are quite helpful, guys. Trust me. Let me show you. Start off with a simple example. Struct register. Now I can have like, you get it, right? This is a, now I can use this anywhere. You get it, right? This is a simple, the register is a struct that I have created that contains two constants, one of type string and one of type bool. I can obviously do stuff with this function print entry. How do we use this outside? Do you get this? Now do you get this? So I have like a couple of values, one of type string and one of type boolean, and I have a function here. I'm just instantiating that using one entry, which I'm then printing out using the function that's already present inside a struct. Now if I have a struct here written inside a file for a specific operation, I can use the same struct wherever I want throughout the application, thereby reducing the complexity of the entire code base a lot. You get it, right? Now structs are quite helpful. Structs you will be using a lot inside your own applications when you start to play around with them. Let me show you a different example. Let me show you a better example than this. There is also like a thing that I wanted to show you. You can write like a mutating, say for instance, assume that this is a variable. Now if I want to show, if I want to change this entry, I can't do this right away. I can't do this. But if I use the mutating keyword, if I do one like this, then I can change it like this. You get it? Let me show you. Can you see this? I hope you see this, right? The first time it's called print entry is called Raja and entry or true. But the second time it's called, the thing has been toggled. I have written a toggle state. I have made a toggle status call here. So the entry is now toggled, and the second time the print entry function, the same function is called, it's now false because it has been toggled. So yeah, to change a value inside the struct, you need to specify this mutating keyword. And even if you specify a mutating keyword, only variables can be changed, constants can't be changed, right? Let me show you one more example of structs which actually has a function that will compute something before actually returning it. So let me just create one more struct, registry, and let name now I have something called net marks. Fine. This will, what this will do is it will return a get marks plus internals. So this will return a total marks. Now this guy should be getting 85 marks, right? Internals he has scored 20 and marks his actual score is 65. Now what I can do is I can simply write another function here. You understand what I'm doing here? If I call this variable, since this variable has a computed problem, this will compute this and return this here, which will in turn get printed here, right? So if I watch this, let one more registry what am I doing? What's this? Let's remove all these. You can see this, right? 85. This is nothing but the marks that is computed here right away. So you can write variables with trailing closures that can compute stuff for you before actually feeding the dev. This can be quite helpful in a lot of ways, guys, especially if you write fintech applications that involve a lot of calculations on the fly. If you write functions like this, if you write stuff like this, it could be quite helpful while you are retrieving information when you are using a struct. Fine. So structs rather help us reduce the complexity of our code base. Let's move on. Let's move on to some other interesting stuff. Structs alone, I could talk about like even more, since there is still a lot more to cover. But since, like I said, this is a video for beginners, let's move on. Let me talk about property observers. There is something called property observers. Say for instance, if a user is online, it should show online, whereas if he has moved away from his keyboard, it should show offline or away, and if he has logged out, it should show offline, right, or signed out. So in that case, let's say for instance, I'm having a struct called sample, and then where some status equals online. Here I'm once again writing a trailing closure, did set what's this? Notice that I haven't touched anything. Here it's online initially, and whenever it is being set, it should print status is now away offline. So if I am just running this now, watch what happens. Status is now away. Since it's being set here, this will get involved. This is just like observing what happens to this property. Whenever there is a change in this property, it's immediately saying this is like a rather simple example that I'm showing here, guys. In a real application, what you would do is, if it's being set to offline, then you should obviously clear out his locally stored data and then like sign him out of the application. It's like a signal, more like a signal that you're observing based on the user status. So if he is like setting it to away, then you should probably call another function that will denote that the user is away throughout the entire application. So yeah, that's how you do it. You do it here, guys. Let's move on. This is one more thing that I wanted to show you. Property observers are an interesting aspect when it comes to writing large applications. There is something called access control. You probably know there is private, public, private set. I think private set and file private. Let me just show you private set because I like that a lot. Struct private, public. You know, public is to denote that it could be used anywhere, whereas private is for that specific struct. Wait, I'll show you. Struct student marks. It can be set, but it can't be like modified. It can't do like one dot marks plus equals 1. I can't do this. You can see this, right? So I can't. The setter can't be accessed from outside the struct if you set it as private set. This is quite helpful if you want to instantiate a particular, I mean, if you want to like create a particular variable that holds a struct object, but you don't want that struct object, the value inside that, to change anywhere or be modified anywhere throughout the whole app. So in that case, this private set var would be quite useful, guys. I have found it quite useful. Now let's talk about classes. So you might be very familiar with classes if you had written or worked with any of the recent, any object-oriented programming language. Classes are nothing but, okay, let's see it with an example. Say for instance, I'm creating a class laborers. Fine. And this contains some properties, let id string, and this has a class initializer. Cool. Now I have a function inside this class. To access anything inside this class, you need to create an object, right? And when you are creating an object, you need to initialize this. Anyway, I'll show that. So I'll create one more function inside the class. Right, we have a very simple class here, right? So let's just do let employee details equals laborers. ID is a string. Okay. For run this now, let's see what happens. Right, now we have a class called laborers. It has a property and an initializer, and it also has a function called print id, which will print something. That's it. Now you can have like derived inherited classes from, child classes from this, which inherit the properties of the parent class. Let's see an example of that as well. Class foreman, now it inherits from laborers. So function get id. This ID is from here. You get my point here, right? This property is inherited from laborers class. Also, I can like this function, if I want to change the ID, I can't change the ID as of now. So if I want to change this, I can simply do a override function print ID, print my new ID is okay, this is not new. Here originally the function prints my ID is and just the ID, right? But if I want this to be changed, I can change it here like this. I can do any code here, guys. Any logic or any code here. Here I'm just showing a very simple example, right? Now what happens here. I need to create it for 4. So this piece of code overrides this function, even though the function names are the same. This overrides the function here. If I remove this, what happens? If I remove this, it will throw up an error. See? So obviously we are overriding that function, and this will change whatever is here under this particular function, right? So yeah, this is one way of doing it, guys. This is what's called inheritance. If you are familiar with object-oriented programming languages, this is an important concept that you will get to know. Let me show you one more example. Cool, right? Now we have a class, an initializer, which accepts a fruit, which is a bool value. Let me write a derivative class hook vegetable that is sweet. This is again a bool. Now what's this? Init is fruit you get what I'm doing here, right? This is an initializer of this class, which initializes a value of this as well as the property which got inherited from its parent class. So in this case, what you need to do is self.isSweet equals is sweet, whereas here you need to do super.init is fruit is fruit. This is because this is the super class, and this initialization should happen here, right? I mean, you can't simply initialize a property that was derived from another class. So that's why we are using the super keyword, right? So yeah, this is how you do it if you are like, I mean, if you want to create a, there is no print function. Then how would I show? So say, okay, let's just say for an example, you are creating like a object for this. Watch what happens. Now this will be initializing. This is the initializer written here for this, and this will accept 2 values. This property is inherited once again from here, this vegetable class. So it also initializes a property of the super class. So this is how you can like initialize a property which is present in the super class. Let's move on, guys. Let's move. This will be, I'll show you like practical examples later on in the upcoming videos. Right now, this is just a beginner video. An important thing here to notice is that all instances of the same object contain the same value. This is an instance that's created for this. This is an object that's created for obj1, and obj1 is nothing but obj2. But if I create like a new one, say for instance, where obj3 equals my name, and obj3 dot name equals Mike or something, print obj3 dot name. Watch what happens. It's Mike. You get my point here, right? This is a new object that's being created, and this object is the one that's being shared here. So if I change it here, then obviously it's nothing but the same instance being shared across 2 variables. So it's just reflecting Steve. Whereas here I'm creating a brand new object under obj3, and if I change the name here, then obviously it's going to take up the new name. So these two are 2 different objects, even though they are created for the same class. That's my point. Let's move on. I think I'm elaborating too much on certain stuff rather than just objects are created and destroyed. Okay, that I needed to explain. Yeah, objects are created and destroyed all the time, guys. Objects are, I don't know why my A is not working. Created and destroyed every time. For this, I'll show you an example. As some of you might have noticed, classes need to be explicitly initialized. They need to contain an initializer function, whereas structs don't need that. Self dot counter id equals counter id, and what print created. There is something called, like say in Flutter we have destroy, right? Similarly, there is something called dinit. You can see what I am doing here, right? So this will be created, this obj11 will be created when the loop iterates over, it will be created again, and when the loop iterates over, it will be created again. So if I just run this, created when it was 3, and then when it was created again, the first one that was created was destroyed so that the second one could be created, and when the second one got created, it got destroyed again, so that when it's running one more time, one more iteration, it's created again. You get what I'm trying to say here, right? You cannot have two objects with the same name. obj11 is the name of the object that's being created, and you cannot have two objects with the same name. So that's one thing that I wanted to show you guys. And there are like other stuff that we can go into in depth in classes, and I'll maybe make a separate video on that later on. But now I wanted to show you one more important aspect of Swift, which I feel many of you guys would like, which is protocols. Now let me show you an example. Protocol house. You guys get what I'm doing here, right? I have a protocol, created a protocol called house. Now what's a protocol? Okay, let me finish doing this, and then I'll tell you why we did that and why we function house rate. It has two properties and two functions. Now if I create a struct based on this protocol, the struct should conform to everything inside this protocol. Say for instance, I'm creating a struct. Now this struct should conform, you can see this, right? The error should conform to protocol house. Protocol house has two properties and two functions which need to be present here as well. Name equals green, where current members 4. There are two functions. The first function I'll write house rate for price int, this one, price plus 60, let's say price plus 60, and function resale value, resale price print. This house is valued at resale price. Cool, right? Now this is a struct that conforms to this protocol house. What's this? Function decide house. This is a random function that I'm writing somewhere else in the app. Decide house. This should You get what I'm doing here, right? This protocol is the one that's going to be used as a parameter here, as an argument here inside this function. So if house rate for price greater than 1000, whatever price I'm passing here, first it will calculate the house rate, and then if it's found to be greater than 1000, it will show out of budget. Else it will show this house is valued at the resale price, which is the price that I'm passing here. I have created an object for this struct. I have created an instance of this struct, and I am passing that as a parameter to this function, right? Now, if I run this, watch what happens. This house is valued at 500. So this else part is being executed, and this is okay. Now, say for instance, I am doing 1000. Out of budget, since this will be calculated, and since it's 1560, which is greater than 1000, it's showing out of budget. So what I'm trying to say here is you can have like a set of you can have like a protocol, and every struct that's being created for that particular protocol should adhere to the properties and functions present inside that protocol. So it's more like defining a predefined set of protocols and then ensuring that whoever is using that protocol, so whoever is creating their own structs and conforming to that protocol, whoever is creating their own structs could use the properties inside that protocol by conforming to it. That's the reason here. And protocols come in quite handy when you need to like create a new calculated value or computed value on top of an existing. Say for instance, there is arrays, dictionaries and sets, right? All of them come under a protocol called collections. So if I want this struct to be based on collections instead of this house, or to be on both, I could just give collections. Now let's talk about extensions. Extensions are nothing but, like I said, you can extend certain functionalities, inbuilt functionalities to suit your own use case. Say for instance, I'm trying to extend a double. So extension double, mutating func calc prices self equals self plus self into 0.18. Okay, this is a simple function that will work on top of the existing double data type that will provide me a price plus 18% tax on that price. To use this extension, what I can do is where cost price equals 149.99 and cost price dot calculate prices. Now this calc prices is not a function that was previously existing on this double data type. We have written a specific extension for double data type, so whichever value is a double value will now be able to use this calc prices function as well. So now if I just do print cost price, if you run this, you can see that it's not just, it's adding this 18% tax to let's say for, okay, let me just, you can see that it's adding this 18% tax to the original cost price based on this extension that we wrote on this double data type and then printing it out here. So similarly, you can write extensions for almost anything, guys. You can write an extension for protocols. I showed you that there is a protocol called collection, right? So let me write an extension on that. Extension collection where is not empty. There is a collection is nothing but a protocol. I mean, all the arrays, dictionaries and sets will conform to this collection protocol. Fine. is empty equals false. Now if I want to check if an array or a dictionary is empty, extension, okay, there's a typo. Watch what happens. Let gg equals hello hi if gg is not empty. Not empty. Since I have two elements inside the array, it's not empty. Initially, arrays won't have this function, guys. We are extending the collection protocol so that now arrays, dictionaries, and sets can have this is not empty feature on top of all the previous functions that they had, inbuilt functions that they had, right? You understand what I'm trying to say here, right? If you want to write an extension for array, here I have written an extension for a double data type, right? Similarly, you can write an extension for array data type, but array, dictionaries, and sets are conforming to a particular protocol called collection. So if it is conforming to a particular protocol called collection, if I write an extension on top of the collection, then obviously I can use it anywhere throughout the program, wherever I want to use an array or a dictionary or a set, right? So that's exactly what I'm doing here in simple terms. That's it. Now let me show you one more interesting thing called optionals. Optionals are nothing but, like, say for instance, if a value is missing or if a value doesn't arrive during runtime, then that would obviously be thrown as a null, right? If you use an optional, you can like guard against that, so your app won't crash during runtime. Say for instance, let ks string, okay, this is a value. What does this question mark do? It denotes that this is an optional, thereby meaning this ks could either have a string or not have a string. This value is optional. That's exactly what it denotes. If let km equals ks, print k. What does it do here? It unwraps this optional. If at all there is a string here, print this. If not, don't do it. That's it. Okay, now it's printing h. It meant to type hi. Now it's printing hi. So this just denotes that this could either have a string or don't have a string. So one way to unwrap optionals is to use if let. The other way to do that is to use guard let. So guard let does exactly the opposite. If it's not that, okay, wait, let me show you. Function check number. You see what exactly I'm doing here, right? So if say for instance this is an optional, if a number arrives into this function, then no problem. But if this doesn't arrive here and there is no number passed down to this function, it should return. I mean, it should print missing string and then just missing number, and then just break. You get what exactly guard does, right? Here, if there is a value, it will print that value, guys. This is one way of, if let is one way of unwrapping an optional. The other way of doing it is using guard. Here, if the value doesn't arrive here, that's when this will print. If it does arrive, it won't print. Here, if it doesn't arrive, it will just skip this. If it does arrive, it will print. Whereas here, if it does arrive, nothing will happen. If it doesn't arrive, it will say print missing number and then break and then return. You get it, right? This is guardlet. This guardlet you will be using across a lot of scenarios, guys. Across a lot of scenarios, especially when doing asynchronous programming. If there is no response returned from the call that you made to an external API or an external URL, that time you will be writing some logic here. This guardlet, okay, I'll show you in the future videos. This is highly helpful when you're doing asynchronous programming. And there is something called nil coalescing. Should I show that? It's actually not even, like say for instance vk equals, okay, and let vv equals double of vk. Here there won't be any double value because vk itself is nothing. So in this case what you can do is just say 5.0. This is called nil coalescing. What this will do is, you can say this, right? If there is no double value, if there is a double value, say for instance, you can see the difference, right? If there is no double value, it will print this. If there is an actual double value, then not a problem. So this is to give like a default value in case no value arrives. That's something you can like do to prevent null or do to prevent the entire crashing of an app just because you haven't handled a scenario. This has happened to me like before, so that's why I brought this up now. Anyway, there's something called optional chaining that I'll show you. Optional chaining. What is this? Let me show you. Let equals, say for instance 5.0. Let mk equals double dot remainder dividing by 2.0. Do you get what's happening here? First, it will get a double value from this. If there's a double value, it will try to find a remainder by dividing it by 2. Here, there will be a remainder. If you divide 5 by 2, then obviously there's going to be a remainder which is 1. So that remainder is printed here. Watch this. Remainder is 1. Say for instance, if there is no value here, then this fails, right? This fails completely. Watch what happens. It will automatically, since there is no mk, it will automatically, this is nothing but the nil coalescing which I have chained with an optional. You can see what exactly I did here, right? This is an optional which I showed you, and this is the effect nil, what happens, how to handle the nil value that's being thrown here. So I just chain both of them so that it makes more logical sense when you are trying to solve a problem, right? So yeah, guys, there's a lot more stuff that we can discuss as we go on with our Swift programming journey. But yeah, this is pretty much it, guys. We have covered a lot of stuff. We have covered data types, conditional statements, flow statements, classes, structs, protocols, extensions, all basics, obviously. And this is more than enough to need if you just get started, if you want to just get started. But as we go on, I'll show you where exactly we are using this and how exactly to solve different logical problems that might arise whenever you start to write an app. And I'll also show you the Swift UI part of it. There is something called a Swift UI which you can like use to create amazing screens natively inside our iOS applications. I'll make videos on that as well if you want. So yeah, if you really like this video, kindly hit the like button and drop a comment below. If you found this helpful, kindly share it with someone and help them too. And yeah, guys, like this video and subscribe to my channel. And I'll talk to you guys in my next video. Bye.